I'm Sohail Malik. I'm a student of Ramakrishna Mahatma Government Engineering College in the Department of Computer Science and Engineering. So today we will discuss about the queue data structure. So, so what is the queue? Queue is basically is a linear data structure and which used to organize the data, and queue is used for temporary storage of the data values. And when the new element entered into the list or queue, then it's called rearranged. And when the elements delete from the list, then it's called the front end. And basically it follows the FIFO algorithm. It means that the first in first out. So now let's see the type of queue. There are four types of queue data structure, that is simple queue, circular queue, priority queue, and DQ. So let's see the simple queue. So what is simple queue? It is defined the simple operation of queue in which the insertions occurs at the rear of the list and the deletion occur at the front of the list. It means that if you want to push some elements 1 2 3 4, then if you want to delete the elements, then at first the one element should be deleted first. So this is the FIFO algorithm. It means the first in first out. So this is all about the simple queue. So next, this is the circular queue. So in a circular queue, all the nodes are treated as a circular, and last node is connected to the first node. And circular queue is also called the ring buffer. And circular queue contain a collection of data which allows the insertion of data at the end of the queue and deletion of the data at the beginning of the queue. So this is the circular queue. So let's see the diagram of the circular queue. So this is the diagram. Here the front and the rear is connected. So this is known as the circular queue. So, so next is priority queue. So what is priority queue? The priority queue is contains the data item which have some preset priority. While remove an element from the queue, the data item with the highest priority is removed first. It means that let's see, we push the 2, 4, 6, 8, and 9 and 10. These all the elements push into the queue, and here the 10 is the largest element. So for that, these have a more priority than any other element. So that's why this is also also present in the top position. So this is the priority queue. So now let's see the DQ. So DQ is also known as the double-ended queue. It is insert and delete operation can be occurred at the both ends, that is front or rear of the queue. So this is the diagrammatic representation of double-ended queue. So next is the operation of queue. So these are the operations. At first, the NQ operation. So what is the NQ operation? The NQ operation, it means that whenever we want to store or add the elements into the queue, so when we use the NQ operation. So now is DQ operation. So DQ operation and remove an item from the queue. Pick get the element at the front of the queue without remove it. This is a pick operation, and is full, that is check for the queue is full or not. And the is empty operation, that is used for the check the queue is empty or not. So these are the operation of the queue data structure. So now let's see the algorithm of NQ. So at first, the we ensure that if the queue is full, then return the overflow. If not, then rear increase the rear and store into the queue and return true. So this is the algorithm of the NQ operation. So now let's see the algorithm for DQ operation. So at first we ensure that if the queue is empty, then return underflow. It means that queue is completely empty, can't remove anything from the queue. So yeah, if else this is the else part. If any elements present in the queue, then store into the data, and front increase the font, then front is increased. So after that, the return true. So this is the algorithm for dequeue operations. So thank you. This is all about the queue data structure.